Welcome back, everyone. Hopefully you're where you're expected to be. We will be continuing with the repository that we were working in yesterday. So hopefully people haven't deleted that and it's still on their hard drive. If you are coming to the workshop and weren't here yesterday, you probably want to git clone that and try and catch up on where we were. But as I said, a lot of the exercises are mostly designed to be standalone. So there shouldn't be too much problem if you're recloning fresh. The only thing you might need to do is go back to update the config file for the rough linting. And if you're struggling with that, they are in the slides, which are linked from the repository. And I think both the repository and the slides, or at least the repository, is in the Slack workspace. Super. So if anyone does have problems with that, please just stick your hand up and I'm sure someone can come around and give you a hand. Otherwise, we will get back in sort of where we left off yesterday. And we're going to start off with kind of, as we promised, moving away from sort of the tooling stuff and talking a little bit more about exactly how we write some of the code or some of the things in and around our code. So starting off with naming comments and doc strings, as the slide says. So the first thing we'll be doing is naming and magic numbers, and the first one of those we'll be doing is naming. So I think we commented yesterday in one of the other sessions that there's sort of this adage that code is often more frequently read than it's run, or more frequently read than it is written. And so actually putting the time in to think about how readable our code is going to be of benefit sort of in the long term. And to do with this, the sort of this concept of self-documenting code, and this is the idea that you would be able to give your code to someone and they would be able to read through it, understand what it's doing, understand all the concepts involved without any need to go and read any documentation. And we should say, before we get much further in today's session, this is not an excuse to say you do not need documentation, but more it's an idea that if someone is coming to the code and reading a specific section or a specific function, they shouldn't need to keep referring back to the documentation for all of the things. And indeed, I was working with someone Friday last week, I think, where we were looking at a climate model and we were seeing there's sort of u_rdn_vv_2. And it was a case of, well, this is probably a velocity, but what's it doing? Is it at cell centers? Is it at cell faces? And constantly having to refer back to a PDF just to go through anything in the source code. So the idea is that we'll sort of try and combat some of those things. Sort of a few guidelines or guiding principles for naming things within your code. So try and declare what the intent of something is. We're probably familiar with this when we're writing functions. If we're going to, I don't know, calculate derivative, we probably name our function calculate derivative. If we're going to read data, we probably name it read data. But this sort of principle also tracks forward to variables as well. So if we think of things like temperature, there's a lot of things that a temperature could be. Can you try and explain that a little bit more based on the context of what it is in your code? And the key thing here, I think, is think about how you might read something. So it might make sense whilst you're in the flow of things to type some little acronym, but think about how would someone else then read this? Would it make sense to them? So the second one is thinking about sort of, well, yeah, it says readable, pronounceable, memorable names. So an example of where I say sort of think about the acronym you're using. In the flow, in the moment, MUS for mass might make sense. But then what does that mean to someone else coming later? Is that meters per second? Is that meter seconds or something else? And so it's not sort of too much to extend to a full name mass. It's then very clear what that is. We're no longer using punch cards. We're not limited to 77 characters being charged by the letter. So you can do that. The other thing with this is, like I say, making them memorable so that it makes sense to what it is in the code, but also think about making it searchable. So if you're editing your code base at some future point, or you know that oh, I calculated mass. Somewhere in my code, there's a function to do that. If you can search for mass rather than trying to remember what the name of that variable you gave it at the time is, was it MASS, was it M, was it MS, was it MSS, is going to make life easier for you. So and then the other one is, yeah, sort of a corollary of that is avoiding abbreviations and single letters. So some of the people yesterday in the Git course opened a couple of pull requests to add gravity as a parameter into the code, which is a really good suggestion, but opened it with gravity being labeled as lowercase g. And yeah, lowercase g mostly we know is the symbol for gravity, but actually adding something a bit more clear, I think my suggestion on their pull requests was to maybe use grav or something else to make it clear in the intent here. Okay, so yeah, the next one is sort of talking about how we label things. So we said a moment ago, we've got, when we label functions, this might be calculate something or get something. But you should try and make these consistent throughout your code base. So if you've got something that's querying several different APIs, maybe you're looking at fetching someday a function that fetches from Landsat satellites, a function that fetches from the GEOS satellites. Don't name one fetch and one get. Try and name them all get something something, all fetch something something something. Again, this is sort of for ease of you then working with stuff. If you know what a fetch function does, you can understand it. And then at the same time, if you're needing to search through your code base to get things, it makes life easier there. And then the final one, I think on here is sort of comes into the consistency as well, but sort of to do with not making things overly verbose or repeating things that people can already see. So if you're using, if you've got Boolean, or sorry, if I start with the sort of storage types, this is the idea of not adding, some people have this tendency to add the type of the variable onto everything else. So something array, something dict, something. If you sort of set your code up, defined variables, broken it down, nicely structured, this should be clear to someone from either the documentation or from where the variable is defined. Sort of, you're just adding more jargon and more clutter to the readability. The second one is if you're using Booleans, you might have a Boolean called I don't know, plant to define is something a plant or is something an animal, but it's not initially clear what plant is. Maybe plant is a class for a plant type. Maybe plant is sort of a logical variable that tells us what kind of phenotype of plant we're using. Try and make it clear in the variable name is plant. We know it's going to be a Boolean, true or false. It's going to be much easier to read and make use of. Okay, so any questions, I guess, at that point before we move on? Super. So the next thing to talk about is explaining variables. And so this is a concept where we're sort of adding variables to our code. So it is adding text, but the hope is that it makes it much easier to read and easier to understand moving forward. So the example here is we've got something for calculating, I don't know, bus fares. And the first function we've got up here is we're going to say if someone is under 14, then we return £3 for the bus fare, I guess. The government just put it up, I think. But if you came to that and sort of you weren't familiar with the code base, you might wonder sort of why is this breakpoint here? What are we making the decisions on? If we add sort of this intermediate variable here, then it's now very clear to us that the condition we're making our decision on is whether someone is a child, we return a child fare, otherwise return a full fare. And the condition for being child in this particular case is under 14. So this is sort of very useful in smaller scripting code. If you're using sort of larger compiled codes, there's maybe a discussion to be had that you are going to be increasing memory usage. So I should have said at the start, sort of some of the things we discuss here are not hard and fast rules. The idea is more that you'll take away some of the concepts we're discussing today and try and apply them in sort of where appropriate to make what you're doing a little bit clearer. So the next, so a good example of this is here. So can anyone see what this line of code is doing? And much like yesterday, oh, wrong one. Can anyone see what this line of code is doing? Or sorry, these two lines of code is doing? Hopefully they can, or maybe it doesn't work.
Searching for a phone number that matches the regex pattern.
Yeah, exactly. So yeah, regex is notoriously difficult to understand. Here we look at it and say, well, we're doing some kind of matching, but for what? Whereas now we've been explicit down here. This is the phone number. This is the regex for a phone number. That's what we're searching this text for. So before we move on, is everyone? Oh, are there any questions on kind of naming concepts? Yes, Sophie. Yes, that's a good question. So IJK I think is fine because that's kind of a commonly accepted programming paradigm. I'm thinking more of people who are writing out equations using maybe A, B, C, D. There's also an interesting discussion here in that if you're maybe working with a set of physical equations that are defined with common terms, so say, I don't know, let's pick, say, fluids equations. If you have V, U, rho, I guess rho would be 3 letters, but sort of within a confined function, I think that's perfectly sensible, especially if you can provide a reference back to that material. Where I'd be slightly more wary is if you had your entire code base sort of making use of a single letter variable everywhere, and it becomes difficult to pick these out. And there's also a discussion of if you're doing it, maybe if you just have U and V for velocities, that's all right. But if suddenly you're amassing sort of 30, 40 single letter variables, things are going to get a bit confusing. And I think it is also one of these sort of legacy concepts that falls over or comes over from when the number of characters did matter. There was a tendency in a lot of scientific codes to just name things A, B, C, D, and you would have to go and look up in a lookup table. Cool. Yeah.
In your previous example, what's the benefit of making it a new variable, not just adding a comment?
Yeah, it's a
going to add like additional memory. Surely adding the comment would make.
Yeah, I think that's a fair. Yeah, you could do one or the other, and like I say, there's no kind of hard or fast rules at this point. Here, that probably would have made a lot of sense, but for an example that will fit on a slide, we need to pick something trivial-ish. Yeah.
Yeah, maybe I can add that. Sometimes it's also that maybe this thing will appear later on again or so, and then you would need to check that all the way back.
That specific.
Yeah.
Yeah, so in this instance, you might have the phone number regex appearing again later. So reusing that. Super. Okay, cool. So the next thing to talk about is magic numbers. Has anyone come across magic numbers in code before? Cool, yeah, a few people. Does anyone want to explain what a magic number is? Yeah, exactly. So so to repeat for the recording, I guess, it's when you come across these things in the code and the sort of I don't know, a 3.45179, and you sort of look at it and say, cool, someone put that in and understood what it was at the time, but now I've come to it and I've got no idea what it means. And the problem with these is, yeah, you come along and you read it, you've got no idea what that's trying to implement. At the same time, it makes things quite hard to maintain, and we'll see that with an example in a second. And it also makes things sort of quite hard to adapt, because if you need to change any of these, you've got to go hunting through the code for the different instances or where exactly they are. And so there's a few things that you can do to handle this. So actually the bottom one of these here, that age 14 would have been a magic number in that previous example, and so one of the options would have been to add a comment to explain it. The other things you've got are to add variables that convey the meaning, we've discussed a moment ago, or more generally is to set something to kind of a constant that you can then reuse throughout your code base, as we were talking with the regex example momentarily. So to illustrate these, this is probably familiar to anyone who was in the intermediate Git yesterday, but we've got a little module on the side here, which is implementing a bunch of kind of the simple pendulum equations. And it has a number of the flaws with magic numbers in it that we'll go through. So the first one is that on the left-hand side, you'll see we've defined this 9.81 for gravity throughout the code. This is fine, it's correct, but the problem is, say someone comes along and says, I now want to run pendulum equations on Mars, or I want to get the period of pendulum on Saturn. Then it's going to result in us having to hunt through changing this number here, changing this number here, changing this number here. Whereas what would be far, far more simple is to just define one single constant up at the top, reuse it throughout the code, and then if we want to change the gravity parameter to do other simulations, we only have to change this number in one place and it knocks through. The other comment as an aside there, because this did come up with some of the pull requests yesterday, is that in Python, there's a tendency, if we're going to define constants, to use all capital letters. And that's something I don't think the formatters and linters pick up, because it can't, the way they analyze the code, it can't be sure what is or isn't a constant. But it's, yeah, sort of the accepted practice is to use capital letters for constants. Okay, so the second example we've got is trying to explain something with a sort of this intermediate variable. So here we've got something that's checking whether our small angle, so all of these pendulum equations are based on the small angle approximation, and we've got a little function that's just going to check for us whether that's valid. Down here, it's not particularly obvious what we're doing. We're doing sort of pi over 1800. And doing some kind of comparison, whereas on the other side, it becomes clear that the pi over 1800 is actually the variable we're setting as an acceptable small angle for this approximation, and then gets passed forward. There's also the advantage here that now, rather than being hard-coded into our source code, it is an option in the function such that if we did want to adjust this at any point when we're using that function elsewhere, we could do. And the last one here, so this is calculating sort of the beats per minute based on the pendulum period. Previously, we had this sort of magic 60 in here. That 60 is not being used anywhere else in the code. So arguably, we don't necessarily need to define another constant called sort of seconds per minute. It's maybe acceptable, again, matter of taste, but I would argue to leave that 60 there as it is. But it's just helpful for sort of people coming along, reading this, thinking, what's this for? Just to give it a quick comment to say, this is where the 60 comes from. Okay, any questions there? Nope. Super. So exercise 5, which if we go back to the code from yesterday, and as promised, you've probably deactivated your virtual environment, but we can boot straight back into it and all of our dependencies will still be there. So if we go to exercises and number 5, you'll see that the example we've just looked at with the pendulum equations is in there if you need to recap it. But if you open and take a look at the precipitation code, and the idea is to go and look for any kind of method or variable names that you think could be improved. And then after this, go and have a look for any magic numbers that might be sat in there and adopt, in the case of both of these, adopt what you maybe feel would be the best solution to each of them. And there's a reminder of some of those things in there. So I'll give maybe 5 minutes or so for that. If anything in the code isn't clear, you can maybe skip or take a quick look forward to one of the subsequent exercises where it might explain what some of the variables are. But give it a go at least of trying to locate the things that could be improved before doing so. Okay, so the possibilities, I suppose, are not quite endless, but does anyone want to give an indication of some things that they came across? Yes. What is your comment?
This probably be set at the beginning, that it's then easier to change or something that could be changed later on.
Yeah, it's a good argument. Whilst we're on this function, anyone got anything else they might suggest with that? Yeah, exactly. Okay, anything else? I'm wondering what's this 86400 here? I feel it's one of those, if you know, you know. It's the number of seconds in a day, yeah. Which, well, I feel it's one of those things that when I questioned this the first time I saw it, someone sort of said, well, yeah, it's the number of seconds in the day. This is in all sorts of codes. But you sort of sit and think, well, it's in all sorts of codes, but someone is going to come to these code bases for the first time at some point. So how might we resolve this one? Yeah, I just said in this case, a comment's a fairly sensible suggestion. Anyone got anything else that they sort of thought was interesting to talk about? So I can actually, that's not as helpful a way of looking at it. If we look at the difference, so yes, indeed. So setting a variable for the upper bound of precipitation, that was a good call. Coming down here, what have we got? Yeah, here, naming sort of figure and the axes. This might help. I think fig and ax is relatively commonly understood in Python, so this one's maybe a matter of taste, but there's a suggestion for that one there. Here we are. Yeah, there's an ANN, making it clear that that's annual might be something useful. What else have we got? Oh yeah, here we go. Create plot. That one's awful, isn't it? Because with this code's generating, as we sort of saw yesterday, 6 or 7 plots. So being explicit about exactly what this is doing is going to be helpful for us. Super. Oh yeah. So another one here, GL, being explicit that GL is grid lines. That one's useful. I think that covers most things. So anyone, any other questions on that before we move on?
Like there's some kind of agreement that would still not necessarily be that moment, but made it even more explicit.
Yeah, I think that makes it clearer. There's still the question of, is it Is it clear what the 60, and the 24 are? Probably at that point. But again, no one's charging you for characters anymore. So adding that extra comment in there isn't going to do any harm. But yeah, making it explicit, it's going to be slightly more computational cost because you'll have to do those 2 multiplications. But I strongly suspect that won't be the slowest bit in our code here. So yeah, that's an interesting suggestion. Okay. So the next thing to talk about is we've touched a little bit on comments already, but actually to talk about the things that go around your code to make it easier for people to understand. So comments and doc strings, the first of which we'll start is comments. And I think, again, as re-emphasize here, that this is very much kind of a somewhat to taste or somewhat to the conventions of your existing code. Different people will have different opinions on comments. Sort of what I would hope to do today is give you some of the things to at least think about when you're deciding what to do there. And so there's a few quotes I quite like here, which is coming back to some of the ideas about naming our variables. The machine code that gets translated is just going to give everything addresses or whatever else, but the code isn't for the machine to read, it's for people to read. The compiler is going to change it into something for the machine. A second one is that sort of emphasizing that this is a matter of taste and you shouldn't go overboard, is that bad comments are worse than not commenting at all. And this particularly ties into the fact that if you're commenting your code and then you come along later and make changes, perhaps maybe our data set changed and our data set now outputs daily averages or hourly averages. Maybe we update that number in the previous example to be 60 times 24 or just 24. But if we've left the comment above it that says you like multiply by something to convert from seconds to hours, suddenly there's this mismatch between what's in there, and it actually, rather than aiding the understanding, could lead to confusion. So yeah, there's a lot more discussion on this particular source there, which is sort of quite a nice little discussion to read. So whilst I did say sort of there's no hard and fast rules, there are some things that I would very much encourage people to avoid. So the first one is dead code. So we've now been through our Git tutorials, whether it's the beginner or the intermediate, and we know that we can commit stuff to a repository, make some changes, commit those new changes, but we can always get back to what was there beforehand. So I would encourage you not to leave in sort of old bits of code all commented out in a big block. If this is committed to a previous version, you can always go into the GitHub history, get it back, be that copying and pasting or doing something fancier with Git. But for the meantime, it's just going to sort of clog your readability and stop you understanding what those things, sort of where the sequential lines of code are. The second one is sort of doing these variable definitions. People sort of have this tendency to over-comment bits of code. If something's relatively obvious, or it can be improved in a way of sort of within the code itself. So here, perhaps we would be better off actually renaming some of these single letter variables, force, mass, ACC, or acceleration. And the last one is sort of just plain redundant comments. So the number of times you have people commenting things like increment I on I plus equals 1, or even more mundane examples like this. If it's plainly obvious what you're doing, don't add more stuff. Sort of comments should be used to taste, I guess, as the recipes would say, rather than liberally. So some more general thoughts on that, or sort of extending that is sort of you shouldn't be duplicating the code. So I guess that applies somewhat to this redundant comment here. Sort of the code already tells us what we're doing. There's no need to repeat what's already been written. Good commenting also doesn't excuse bad coding. So we've said that we might use a comment where something's not immediately obvious, but that doesn't mean that writing a comment to explain some crazy one-liner NumPy that we've done is acceptable if there's going to be a clearer way of writing that. And yeah, if you can't explain something sort of with a nice simple comment such that it's obvious to the reader, it's possibly an indication that maybe you want to go and revisit some of your code. However, if you have particularly unidiomatic code that's not very obvious, then it can be useful to explain this in a comment. So I realize this is sort of conflicting advice to the point above, but it's a matter of kind of exercising sensible judgment and thinking about if someone else were to come along to your code, or even maybe if you've got something you're not sure about, ask your lab mate or someone else in your lab to have a read of it and say, if I gave you this, can you understand what this is doing? So the other thing I would say is if you've got some copied code in there, you've been on Stack Overflow and sort of pulled someone's really nifty solution to do the particular thing you wanted. If this is more than sort of 1 or 2 lines, it might not be immediately obvious as to why that solution works or exactly what it's doing. So if you can provide sort of a quick link to that source, maybe where there's a discussion or more explanation, that can be useful. And then also sort of any external references where that might be particularly pertinent. Though, again, I'm not suggesting you stick in links and references every other line of your code. Just exercise some judgment on where it makes sense and where it might help someone else in future to understand exactly what you've done. Or there's maybe people have come across this where someone comes along with your code and says, can you explain to me why you've done this? And you sort of say, oh, because I copied it from somewhere. Well, maybe that's fine. But if you could then say, I copied it from somewhere, but this is where I've copied it from, and you can go there to understand why, that might help. And then finally, after all of this, sort of my main comment is to say that your comments are not a substitute for documentation, which segues us nicely into the point that comments in your code are going to be read by developers, people who are actually going in, reading the source code itself and modifying it. They're not necessarily going to be read by the users. And so information to provide to the users of your code, people who are maybe going to want to be running it rather than developing it, is for going in doc strings. And these are kind of, is a system that's set up to manage sort of the proper formal documentation within your code. So before we talk about that, does anyone have anything they want to ask about comments? Okay. So doc strings is kind of a common term, a portmanteau of documentation and string. The idea here being that it's documentation within the code, sort of in a longer string format, but it sits alongside the code and describes how we use various bits and pieces. So in Python, you may well have seen these in places if you've ever looked at kind of maintain source code. And in Python, they're denoted with these kind of triple quotes, and they will appear at the start of functions or at the start of classes. And coming back to yesterday, there is indeed a enhancement proposal 257 that tells us a bit about what the doc strings should say. So this is things sort of saying what should be in there, what shouldn't be in there, setting some kind of standard content. So can anyone maybe suggest what things might want to go in there? Slightly harder, I guess. Anyone think of anything that maybe shouldn't go in there that you might be tempted to include? Yep.
All the variables that are not defined in function but are like defined inside the function but are not a part.
Yeah, excellent. Yeah. Yeah. Are you saying that should be in there or shouldn't be in there? Should be. So yeah, some examples of how we might use the function. It's a good suggestion. So yeah, PEP 257 tells us about what should and shouldn't be in doc strings. But in terms of how we actually write these, what format, what layout they have, it doesn't sort of put any constraints on that. And this is where there's then docstring format guidelines that different people impose. And there's a few options for these that tell us actually how do we set these out. And the benefits of having kind of a pre-prescribed layout to our doc strings is that a bit like when Arfon was talking about with syntax trees, is if they follow a standard layout, we can actually give our doc strings to a computer that can parse them and then turn them into something more formal or more accessible. So a lot of people have probably been on read the docs websites for Python modules, and you sort of think, wow, someone's done a really nice job of giving a description of the functions, all of the types it expects, the names of the variables, and things else. This is all generated automatically from the doc strings that are stored next to our code. And the other benefit of doing that is that when we update the code, we update the doc strings, and all of the documentation beyond that point sort of trickles down to be updated in line. So there's a few options for these. NumPy has a sort of a set of conventions. Google has a set of conventions. There's other options kind of using restructured text. Here in this, sort of these examples, I'm going to follow the NumPy sort of the NumPy format for doing this. And this is because it's quite widely used within scientific code. So NumPy, of course, follows these doc strings, but SciPy as well, and a number of other kind of common scientific Python packages. And there is full guidance for this on the NumPy doc. So you'll see that they set out sort of in order of the different things to be included. They give us what should be in here. So section 1, they suggest including a short summary. A few other options. Then we've got a list of all the parameters. After the parameters, we have things that the function is going to return. And then there's a few other optional sections, and I think somewhere towards the bottom, as was suggested, is including examples as well. I think that's, yeah, this has been mentioned already. So here's the things that I would argue a doc string has to contain. A short description of what we've got, what goes in and what comes out. The other things we've had discussed were usage examples, so there. Another thing you can do, so what's often encouraged with the NumPy doc strings is to have a very short, snappy description of the function so that someone can read it and immediately see what's going on. But if you then do need to do a bit more verbose explanation, maybe you need to clarify what some of the parameters are or how they're being used, you could then have a longer description that someone could read. You also might like to put in there any information about errors that might be being raised. So if someone is trying to use your code and it spits out a value error, giving them some indication in the documentation of why this might be happening could be useful. And then finally, something I found useful when writing scientific code is actually you can include some key references in there. So if you've been implementing an equation from a particular textbook or from a particular paper, put in sort of the DOI to that paper or a link to the book title and chapter, something else, such that if someone's reading this in context and wants to understand it further, they can follow up on that link if necessary. And so how do we set these out? In the NumPy convention, we'll have our triple quotes at the top and the bottom. We then have our short one-line description as the first line immediately below the first quotes. We then have parameters followed by a line, and parameters here is inputs to the function, anything it takes as an input parameter, funnily enough. And the way of setting these out is we have the variable name as it would appear in the function call. We have the type of the variable, so whether it's an integer, a float, a boolean, etc., etc. This is going to help in making sure that people are using your function appropriately. You don't have to restrict this to kind of just one type. You might want to say, well, I know that this function can take integers or floats, or maybe this function can take floats, but it can also take arrays. You can give this here. And then much like our short description of the function, we have a short description of that particular parameter so that people know what it is in context. The return values follow very much the same format, so I won't go through it again, but they're just listed under and the returns list here. So if we look at that, oh, there we go, in context, with a little bit more as well. Here is an example from some code that I worked on previously. So this is calculating, if anyone's been involved with plasma or space weather, this is going to calculate what we call the gyro radius, which is if we've got a charged particle in a magnetic field, it's going to move in a circle. And there's an equation based on field parameters that will calculate the radius of that circle. So the first thing here, we've got a short description of what this is going to do. Secondly, you can see here we've got the various parameters it's going to take and the types of those, but then also a description for us. This is followed by the returns value. So in this case, there's only one, which is the gyro radius of the particle. And then finally, under here, I've got notes, though I think this could also have been labeled references, is actually a link to where this equation has been pulled from, where you can go to look to see more information about it in context, if anyone's sort of wanting to use this in their code. So any questions there? And I'm also realizing this. Yeah, does anyone have any questions on that? No, super. Okay. Yeah, okay, super. So you might be thinking, much like we did with the formatting stuff earlier, there's no way you can possibly remember all of these rules, all of these things that are meant to be in there. Make sure that you're going to catch any variables that change, any variables that are renamed, added, removed, etc., etc. And so this is where again, there's a set of tools that we can use in our code. So you remember at the end of discussing rough yesterday, we added an extra set to the rules in the config file, which was D for PyDoc style. And so this is sort of an extension to those rules that's also going to scan in addition to our code and give us some warnings about that. So as an example here, you can do this just by running rough check, much as we did yesterday. But you'll see now that we've enabled those additional things, we've got some additional warnings. So here, it's raised a couple of things for us. So one is that we've left out an argument. So we've left out the magnetic field strength from our doc strings. You can see it appears in the function call here, but we've not got it here. So we've got a reminder to include that. A couple of other things is it's talking about how we should format these things, so where we should add white space or not. And also sort of a slightly nitpicky complaint that the NumPy doc strings suggest we end our function descriptions with a full stop. So yeah, this is useful. You can run this over the code and it will catch for you any problems you've got with missing variables, unnamed variables, or slight violations of the NumPy docstring standards. So the last thing to talk about there is, as we do with all of our examples, other languages. So the doc strings we've been talking about here are specific for Python, enclosed in those triple quotes. If you're working in Fortran, there's a couple of options, either Doxygen or Ford. Here I've shown how we would use this with Ford. So our function description comes underneath and is denoted with these sort of double exclamation points. So it's a comment, but then Ford knows when it scans through the source code to pick up any double exclamation points as source code. And our parameters sort of, again, we can label at the end of sentences. Or at the end of code lines, sorry. Doxygen is the other option, and this is what's commonly used as well for C and C++ code. Here we tend to stick things above where we've defined the function. Slightly different to Python, where it's just underneath the definition, but there we go. And this has sort of the labels you can see here. Again, this short one-line description, followed by param and return labels for things. Julia, I think, as it came after Python, tried to adopt many of the same formats. So takes these triple quotes with arguments and returns. And finally, R, we've got Roxygen, which is sort of built off the Doxygen format and takes a similar style, as you can see here. And as I say, the benefit of doing this is that with many of these languages, there will be tools that are out there that will be able to scan your code base, pull out anything that's been marked as a docstring, and turn it into sort of nice, pretty formatted documentation. So the last thing I would say on that is it can be a lot of work to modify your code after you've written it to add all of this in. And sort of quite time intensive and labor intensive. So I would encourage you to do this sort of from the start or from here on forwards, if you can. And my suggestion would be, don't worry about making the world's best doc strings that can be sent out into the world to be read and understood by everyone. But think about doing sort of the minimum things of a description, inputs and outputs, because this is will end up being really useful to you when you come back to your code to work on it in the future, or anyone else that you might share this with. So any questions there? Super. So the next exercise, number 6, is to work through some of these things. I won't expect you to do everything, but I'd say go through the first bit and maybe look to see if you can spot any dead code or any sort of redundant comments. But what I'd particularly like everyone to do is pick a function that's in there that doesn't currently have a docstring and see if you can try and implement kind of a NumPy compliant docstring, yourself. And if you want to sort of see how well you've done with that, you could try running the rough check with these new rules over that to see if it complains about what you've written. So I give maybe 5 minutes or 10 minutes for that. And as always, if anyone has any questions, comments, or things to share, do stick your hand up.
Yeah, well, just like one function.
Unfortunately, not that I'm aware of. It would be really nice if you could. I don't think you can, but I've never looked. If you were doing this possibly in practice, there is the ability to mark with, again, special comments on certain lines. You can say, don't run static analysis on this function for the exact reason you say, if I know it, like, I know it's going to output a load of complaints and I don't want it clogging sort of my thought space. So one option in this sort of instance would be to disable for functions that you're still working on, and then when you want to come and fix it, to do that. But yeah, sadly, I don't know at the moment. One thing you can do, where have we gone? We're in exercise 6. So one thing you can do is add a flag saying format concise, which instead of printing like all of the source code with the exact pointers, will just give you sort of those one lines like we've had in like we had in the examples. Maybe it's not format. Oh, output format. There you go. So if you use that flag, it will give you a slightly, just give each one on one line rather than the full that one, which could be a little bit much to work with in that case.
You said in your list of things to use comments or not to use them for, that incomplete code was a sort of okay thing to be using for probably incomplete, but
Yes.
and incomplete implementation. And obviously, like in GitHub, you've got issues to point into the code. And I wondered, I use kind of my own marker for like things where I either would like to or definitely have to improve or change the code at some point. Which obviously I then try to copy into the issues, don't always keep up with. Is there any kind of good standardized, like could you put issue in capital letters to etc.?
Yeah, right. So that's a good question. So there is, I don't know of anything official, but a lot of text editors will recognize, and I'm about to be caught out because it probably won't do it. A lot of text editors will recognize if you. No, hang on. Aha. There we go. So a lot of text editors will recognize a capital to do as kind of a universally recognized thing. It may be that there are tools that can pull this out. I think the other one that might be in there, if hang on, I've opened this in. So the other one that might be in there, yeah, there we go, is fix me, is also a useful label. And then again, this can be useful in terms of, we were talking about being able to search our code. If we know that to-dos are always labeled with to-do, or things to fix are always labeled with fix me's, you can also then sort of do a grep on a file or do a grep on a folder to pull out where these might be.
Do I use a triple X and never use
Right.
X for anything else?
Right.
It would be nicer to use.
Yeah, it's the same idea, but then again, we're sort of talking clarity.
Yeah.
To do, we can probably infer what to do is, whereas triple X may have other meanings.
The seriousness.
Yeah. Sort of to do is, it would be nice to have, fix me as a not good, come back.
Like asked you.
Yeah, and so it's sort of a commonly accepted thing that lots of text editors have accommodated. And probably even have more elaborate tools built around in some cases. I mean, hey, you can probably, Cursor will probably come along and sort them out for you.
Just in the previous session.
Okay, so we've had a little bit of time there. Is there anything, I think you will have been through and looked at what you're doing and either fixed things or not. Is there anything anyone particularly found interesting that they'd like to feed back? Sort of, was it relatively easy to add doc strings? Slightly more difficult? Anything you got wrong that got picked up? No? So take a quick look through. Take a look for so. Oh yes, the other thing I didn't mention is that something that Python has as well is if you're sort of looking to build your code or have multiple files, it will often suggest, or you can add doc strings to files as well, because these will become what Python calls modules. So up here, sort of, you've got something describing what's in this file, so someone can come along, have a look, decide whether this is the right place to be in the code or not. Anything else? We've got some dead code that got removed, some doc strings here, more doc strings here. some more dead code that's come out. Yeah, hopefully everyone was relatively happy with following along with this. And if not, do come and find us after the session and we can discuss more. If there's anything else people want to chat about, that's absolutely fine. At which point I will hand over to Marion. Oh, I will. Who's going to talk a bit, as teased in the session yesterday with Git, a bit more about readmes and repo files.
Yep, so you might be pleased or disappointed to hear that there will be no more exercises. So I am just going to talk through basically stuff that you might also find in a repository or want to add to your repository. And I think probably if we're talking from a reproducibility point of view, and if you would talk to anyone who's interested in reproducibility and ask them, okay, what is the most important thing you would want to do everyone to make your code more reproducible, it would be add a README, add a useful README to your repository that just explains what this code is, what you should use it for, and also how to get started. Maybe have a short, quick start example, some information on, okay, what is, so what do I need to install? What are the requirements? Or so, or where do I have to look for this information? If you're really lucky and look into README, you might also find a bit of additional information. For example, okay, who are actually the main developers? Who can I turn to if I've got a problem? Or what is the process of raising an issue, raising a problem that there is, or maybe even contributing to the code base, and how should I use this code base? How am I allowed to use this code base? You will find the README usually as a readme.md, with the MD standing for Markdown, so which is just a specific way of formatting your code, writing your code so that things like links or headers or so are formatted nicely. If you're really interested in README, so because I'll just skim over the most important things, there are websites like makerreadme.com or readme.so, and they also have really good examples of how a good README could look like. And there are even tools out there that can help you create a README, which is basically a form which asks you all the important information that should be in your README, and it will spit out a readme.md file for you to include into your repository. Just going into a bit more detail of what should be into your README. So I would say this side, so it's a bit of a matter of taste again, but I would like to have all of this in here. So all from basically the name of your code base to an overview. And then I really like little copy code sections in my README that I can just take and put into my terminal, and it will just run the installation process for me, and I don't need to go and download something from somewhere. So it's just a very nice quick start thing, maybe a little example that I can just copy and paste and it will just work. So that's the best case, so that I have a very easy way of getting started with that. And then really useful also pointing people to, okay, are we using issues to discuss things? Are we using some kind of Slack workspace or other discussion forum? So how can I get into discussion with other users, or in the best case also the developers of the code base? And then really useful for you as a developer is also putting, okay, how do I want to be acknowledged? If you use my code, I want to be acknowledged in some way. I want you to be able to cite my code base in your paper, or I want to be acknowledged in a certain way. And then something about, licenses. We will talk about licenses in a bit more detail in a moment. And useful thing is also known issues, so that people don't bring up a certain problem in the code base for the 100th time, because there's this issue, and yes, I have to fix this. But just giving this information, okay, be aware of this is an issue. The code base currently just works on Linux. We don't have support for Windows, for example, or these kind of things. And then there are a number of nice to haves as well on this side, which you might want to include in your README. Licenses. This is another really important thing to have in your GitHub repository, because a license tells people, okay, how are they allowed to use the code? So they shouldn't just go away and copy paste and claim, oh, this is my code. Or so you protect your ownership, but you also limit the liability. You can give it a license that says, okay, you can use this code, but I'm not liable for anything that might go wrong, or for your papers having wrong results, or anything that can happen with this code base. And there is a really nice tool called Choose a License, or website choosealicense.com, that helps you to decide what is the right license for my code. So what level of protection should I add to my code base there? As an overview of, that probably depends on the license that a larger model has as well. But maybe if you are looking at this, what's called a copyleft license. So this would mean basically if the code base, so if your code is used somewhere else, it needs to have the same license as the license you're using. So this works if you're choosing this license, that only works if the bigger code base then also has that kind of license. But it's a question about code ownership as well. So if you're writing the code for your PI and he pays you for basically for creating this code for this, so then probably you will have an agreed license to use for that code base. Then in the best case, you are acknowledged in that bigger model. So you're basically one of the contributors to that bigger model, and should be listed as one of the co-authors there. You, of course, if it's like a, so it's depending on whether you've got like a separate repository, so then you might want to put these things there as well. If it's basically a part of that bigger repository, so then it should be agreed with the code owners there, if that's the case you're describing. And will it be coupled, or will it be basically used over there? So will it basically be moved in that bigger repository? No. Okay. Yeah. In that case, you should of course make sure that your part has all the important bits in there. But then also, in the best case, I mean, if that is coupled, so then that should be also mentioned basically in the other repository, if that becomes an integral part of that code base. Okay, just going over basically not restrictive at all licenses and very, very restrictive ones. So you might want to say, okay, this is my code. Don't use it, don't copy it. This is just mine. Or you might say, just use it, do whatever you like to do with this. You can sell it, you can copy it over to your code base. This is free to use. Or you might want to have something a bit in the middle. So you might want to have some requirements, something about, okay, you can't actually sell it or so, or that this is something that you have to keep in mind if you use this. Or as I described a moment ago, there's the copyleft, where you say, okay, these are my restrictions or so, and you can use this code base under these conditions. And if you use it, then you have to use the same license as I have. So you can't go and use it and make it suddenly public domain or sell it and make it basically your own in that case. So some examples of very permissive licenses are the Apache 2.0 or the MIT license, and then the new general public license 3, that is an example of a copyleft license. And this is what the MIT license, just so that you see what it looks like. It's not like pages and pages of text or so. It's just saying basically, okay, you can use the software, anyone can use it for anything. You can publish and use parts of it. You can sub-licenses, or you can even sell the software that uses this. And the software is what it is at the moment, and we are not liable for anything that should happen. So you use it at your own risk, basically. But GitLab and GitHub both make it relatively easy for you to add a license. So this is what you would see if you want to create a license. So you just go to the add file and create a license file here, and then it will come up with this, oh, you want to add a license. So here are some example licenses you could add. So you can choose a license, for example, things like MIT or so will be readily in there. And then you can just select that license from the list, but you can also decide to create your own license, if you will, or a totally different one. And then in GitLab, I'm not using GitLab myself, but I found this somewhere. So I've at the moment not using it. I've used it before. So there, it's also, you can, if you create a new file with the name license, you can here select the license you want to do, and then it will just provide you with the license text. Okay, are there any more questions about licenses? So I really recommend choosealicense.com if you're unsure about what license you might want to use. But yeah, MIT or Apache or GNU licenses are often a good choice. Yes. Just mentioning a couple of other things, other files you might want to add to your repository. I mentioned that you might want to tell people how you would like others to contribute. So you can create a contributing.md. You can also have it directly in your README, depending on how extensive your process is. So if you have a very, very long process of like, okay, we want people to raise an issue and then create a pull request this way, but also we have these standards that we would like to be followed and so on, then you might want to have a separate file for that and not put all of that into the README. Arvon already talked about citation files, so that is very useful if you use a software that create a software that others use. You want to make it very easy for them to cite you and have the right citation. A code of conduct, how you want people to behave, what you want to set as standards for pull request reviews or merge request reviews if you're working on GitLab, and about the tone you want to establish in communications, especially if it's like a big project and there are a lot of outsiders who've never looked each other in the eye, then sometimes people can get a bit I don't want to say aggressive, but unpolite in the way they tell others that their code is rubbish or that they really can't do it like that, and why have they done this mistake in their code base. So you can create a code of conduct.md to just make sure, okay, if you want to contribute, please be nice. And then it might also be a good idea to have a changes.md to document major code-based changes and in the versions that you're doing, so that people know, oh, okay, there might be a breaking change, and if I want to go back to this version that I used for my paper there, I should go to version so-and-so. So in the best case, you've tagged that in your GitHub repository. And if you don't know what that means, then just ask any of us. That is another thing useful to do, just to document big changes. Okay, that has been the content we managed to fit into these 2 sessions. There are way more other things. So we've touched on functions and modules very, very briefly. Yesterday I talked about it when I talked about structuring code. We touched, so Jack very briefly touched on packaging when he talked about requirements. We've talked a bit about documentation and so, but not about how you actually come from the doc strings to your read the docs or whatever. And we've also not talked about type hinting at all. But I think type hinting, we had a session last year in the summer school, so you might be able to watch that on YouTube. Just to name drop a couple of things that could also be mentioned in a session like this. Okay, if you need some further help, if you have very specific questions, or you find this all very interesting but don't know really how to do it, or have anything else you would like some research software engineering help in, we do run the ICCS Climate Code Clinics. So there is an online booking form that any VESRI member can use to say, oh, I've got this software problem and I would really like to discuss it with someone who can help me. Then you can put the little information in there, and we will go and select the member of our team who's most appropriate to help you with this, and we will schedule a call with you. We also have the form that's on the summer school website where you can book a slot this week if you want to follow up on anything. You will see all of the team members there with stuff they are happy to discuss with you, and the time slots they have got for that. If you're interested in learning more about any of these things and a lot more, there are a couple of useful resources to go. You might or might not know about the Research Software Engineering Society. They've got a website, they've got a great Slack workspace as well, where you can ask questions and you can get access to hundreds of research software engineers. But this is not like a big service desk or so. It's more like a community for people who also consider themselves research software engineers. So that might be interesting for you if you're really interested in research software engineering. There has been a series of podcasts and sessions on various research software engineering topics over the past years, called Bite-Sized RSE, which are gathered under the Universe HPC project. Of course, there are the carpentries. They are no longer just software carpentries, but also HPC carpentries and data carpentries, also, which are sessions on various topics around data, software, and HPC. And then there's this website, which is currently work in progress around various RSE topics as well. And here again, like yesterday, how to reach Jack and myself. And there are more references about various things that came up during these sessions. And that's it for now. Does anyone have any burning questions before we finish? Nope. In that case, thank you very much. At 5 o'clock, we can all go downstairs to the hall where we had our lunch yesterday. There will be a poster session. There will be cheese and wine and other drinks. And there will be all sorts of posters. Some are the posters that we have worked, the projects that we have worked on over the past few years. And then there are also a couple of vestry posters and so as well. So see you all downstairs, and thank you very much.